Hey everybody, this is Dr. Kaisa Young. Welcome to Astronomy of Stars and Galaxies, Astronomy 102. It's not the way that I had hoped to meet you, but we will do all our formal introductions on Monday when we can see each other face to face. For now, I'm just going to sort of start on the notes. We're going to be starting talking about our sun, trying to answer this question, why does the sun shine, and what is our sun like? So you'll get an idea through this video of what the classes will be like, at least on some level, and then we'll really get started next week. So the way this works is this will be chapter 1 in your workbook. I'm going to fill in the blanks for you. You follow along with me. You'll also see in your workbook and as on this slide, the chapters that you'll need to look at in the OpenStax astronomy book. That is just for your reference. The tests are going to be focused on the notes, but the textbook, the Astronomy OpenStax textbook, really is there to help give you extra information. So what you see here, a picture of our very own sun in different colors, so to speak, not colors we can see with our eyes, but in X-ray and ultraviolet colors, giving them false colors, so not really green or blue, but in wavelengths that we can't see. And in these different wavelengths, we can see different features on the sun, and we'll get to talk about some of those things, sunspots and prominences that are caused by the magnetic field of the sun. But for today, we're just going to talk about the atmosphere of the sun. This is starting out in OpenStax section 15.1, or in chapter 1 of your workbook. And the notes are in outline format. So I'm going to talk and fill in the details. Feel free to write extra in addition to what I write down here. But let's just go ahead and get started. So the atmosphere of the sun. So we think of the sun as this ball of gas or plasma, but there actually are layers sort of above what we would consider sort of the surface of the sun. So where you have lower density gas than in the sun proper is what we call the atmosphere. So another way to think about it is the density is dropping with increasing altitude. So as you go up away from the surface of the sun, the density of that gas gets less and less. Just like on Earth, as we go from the surface of Earth, we go up in the atmosphere, the density drops. Okay, so there are 3 main layers to the atmosphere of the sun: the photosphere, the chromosphere, and the corona. That's going from inside out, and we're going to talk about each one of those. All right, let's start with the photosphere. So the photosphere is what we think about as the surface of the sun in a way. Let me explain that a little bit better. It's a narrow layer, not a very thick layer, of the sun's atmosphere where light is emitted. That might sound kind of weird. You might think, oh, the whole sun shines. But below this layer, it's the gas, the plasma of the sun is opaque to light. Light can't get through. And so this is sort of the first layer where light is released. That's why we think about it as the surface of the sun. Even though it's gas, plasma, you couldn't stand on it. It goes from opaque to not opaque to transparent. Light is released. Okay, so we have this opaque layer. And so when we look at the sun and we see it looks like a round ball, like in this picture, that's what we're really seeing. We're seeing the top of this opaque layer, this thin, narrow place where light is then released. So it looks like the sun has this surface. This picture of the sun here also shows some sunspots. We'll talk about those another day. Okay. All right, so the photosphere is pretty hot. It's not the hottest part of the sun, but it has an average temperature of 5,770 degrees Kelvin. Kelvin is a temperature scale that we often use in science. We use it because in Kelvin units, Kelvin degrees, 0 is 0 is 0. There's nothing below 0. But I'm going to translate in Fahrenheit. That's about 10,000 degrees Fahrenheit. So it's pretty hot, right? This temperature, this 10,000 degrees Fahrenheit, is known as the surface temperature because it is the temperature of the photosphere, which we consider to be the quote-unquote surface. This temperature, we will find, is related to both the color of the star and the type of star. So I'm going to introduce some of these concepts as we talk about the sun that we'll come back to when we talk about all the different stars. And this is one of them, that temperature is related to color of the star. Our star is yellow, right? Our sun is yellow. It primarily puts out yellow and green light as well as all the other colors of the rainbow, as well as some infrared and ultraviolet. But if we look at stars that are different colors, there are stars that are more orange and red. They put out more of those kind of light. And then there are stars that are more white and blue. They actually are hotter and they put out more ultraviolet and violet and blue light. So we'll come back to that as we talk about stars in later chapters. So surface temperature is the temperature of the photosphere. As we go in the photosphere, so we're still in the photosphere, we haven't left the photosphere yet, temperature and density of the gas decrease as you go outward. Okay, they decrease outward, just like you might expect, like this is what happens in the atmosphere on Earth. So it is hotter in the lower layers of the photosphere and cooler in the upper layers. What this does is something that's actually fairly important for us as scientists to learn about the sun and other stars. Because there's this temperature change from hotter to cooler, the cooler layers, the cooler outer, just to be more specific, cooler outer layers in the photosphere actually absorb some of the light that is coming from deeper in the photosphere. So the photosphere is emitting light at all different wavelengths, all different colors. But as it travels through the photosphere, some of those gas molecules, some of those atoms in the photosphere absorb that light, and that takes away colors. So when we look at the rainbow, the spectrum of light coming from the sun, it is missing colors like this picture below. We call this an absorption spectrum. This is another one of those things that we will get back to, but, oops, and I'm not always the best speller, y'all. We will get back to talking about different kinds of spectra and especially absorption spectra of stars. But I want you all to know that our sun is just like any other star. And this is how the light looks. When we look through a telescope at the sun and we use a prism, essentially a way to separate the light into all of its colors, this is what we see. We see some colors are missing. They have been absorbed by the cooler outer layers of the photosphere. Okay? And this will be important because this will tell us what the sun is made of as well as other things. But we'll get back to that. So continuing on our journey, that was the photosphere. The photosphere is the first layer. That is where light is emitted, the opaque surface layer. Going up, the second layer of the sun's atmosphere is the chromosphere. Chromosphere. So we got the same sphere, right? Chromo now sort of tells us about color in a different way. This is located above the photosphere. Okay? It is oddly higher temperature. So we saw the temperature dropping in photosphere. The temperature went down as you went up, but now we hit the chromosphere and it gets hotter again. This is kind of weird, but it continues to increase through this layer of the sun's atmosphere. So temperature increases outward. This is the opposite of what we just saw in the photosphere, and it's the opposite of what we see on Earth. Why? Well, the sun has a really complex magnetic field. And we're going to talk about the sun's magnetic field and how it causes things like sunspots and solar flares and all these things. It also heats the outer layers of the sun's atmosphere. So when we get up to the chromosphere and then the final layer, the corona, we'll see that it just gets hotter and hotter. And this is just due to this complex relationship between the sun's magnetic field and the thinner gas in the outer atmosphere of the sun. Okay. All right, so if the photosphere gave off an absorption spectrum, the rainbow of colors with a few colors missing, the chromosphere is different. The chromosphere gives off a color, so chromo, color, photo, light. So the chromosphere, it gives off a reddish, I'll just say red. It's sort of an orangey red, however you want to call it, a red emission spectrum. Okay, so the photosphere was an absorption spectrum where colors were missing from the rainbow. The chromosphere basically gives off mostly red light. It emits red from all the hydrogen in that layer. And we'll again come back to talking about different types of spectra. But for now, just want you to know that this is the red layer. Here's some pictures of it. You can see when you look just at this layer, it doesn't look as smooth as the photosphere did. When we use special filters to just look at the red light, we get to see all the kind of funky movement of the gas, and you get this sort of swirly granulated texture in the chromosphere. Okay, so we've had the photosphere, and now we've had the chromosphere, and the third layer of the sun's atmosphere, it's the corona, right? Corona. Okay, and a few years ago, we all became familiar with the coronavirus. Right, that is the picture all the way on the left here, and you compare that to the sun's corona. Corona, of course, means crown, and so you just have this beautiful diffuse crown around the sun in a similar way to the virus. So there's no relation to that. It's just the name suits what it looks like. So the corona is an extended layer of gas that is above now the chromosphere. So above the chromosphere, and it extends way, way, way out into space. It is quite huge, but very, very thin. So it's not a layer that we can actually see. In these photos here, the sun is blocked out with a black disk, right? That's so we can see the corona. We'll come back to that idea, just hang on to that for a minute. So the corona is very hot. As we were saying with the chromosphere, the temperature gets hotter as you go up. And so now we're above the chromosphere and it's even hotter. It can be up to 1,000,000 degrees. Remember, the photosphere, the surface of the sun, is only about 6,000 Kelvin, and now we're up to 1,000,000 Kelvin, so it's much, much hotter. Because it's hotter, it emits a different kind of light. The photosphere emitted visible light that we can see. As we get hotter and hotter temperatures, we emit different kinds of light, and the corona emits X-rays. That's another reason we can't really see it with our eyes. It is very, very thin, which means the density of gas is very low, right? very thin, very hot, very extended, so it's not putting off light really that we can see. How extended is it? Parts of the corona can extend, again, pardon me, extend for several times the width of the sun. Right? The sun is pretty big. The sun is 1,000,000 times bigger than Earth, but the corona extends 2, 3 times further out than the sun. So really, really huge. So I said hold on to that idea that we have to block out the sun to see it with a black disk. What is that black disk? That's the moon, yes. We can see the corona during a total solar eclipse, which we got to experience near here, not in Louisiana, but near here back in April. So if those of you who got to see it, you might have seen the corona. The rest of the time we don't get to see it because the rest of the sun is much brighter. But we get to see these beautiful pictures. These pictures are a little bit better than what you would see with the naked eye, even during a total solar eclipse. But that's what we see. That's why it looks like there's this burning hole in the sky, because we are looking at the corona. So that is it. We have just completed the 3 layers of the sun's atmosphere, the photosphere, the chromosphere, and the corona. If we were in class, I would give you this question. So I'm just going to give it to you so you can think about it. And on Monday, we'll come back and talk about it. This is where we're going to be using the open poll app, and we'll talk about that as well, so don't worry about that either. But for now, I will leave you with this and think about, from hottest to coolers, what are the layers of the sun. Can't wait to see you all on Monday. Have a great weekend.